Hi, I'm Alex Klinger. I'm the lead systems engineer here at Titan Robotics, and we're here in the Titan Testing and Integration Center at the Pittsburgh International Airport. In this hangar, we integrate and test all of the different systems that we deliver to our customer. We provide systems that remove paint from aircraft. We provide systems that apply paint. We provide systems that help our customers apply cold spray, help sand, help buff. Pretty much the standard dirty, dull, and dangerous processes you see out there in industry. We bring intelligence and robotics to industries that need them. So across all of the Titan systems, to bring that intelligence to our customers, we have to sense our environment. We have to understand what is the part in front of us, what do we need to do to that part? And a big element of that is our sensing suite. SICK has a catalog of sensors that help us out. And so for every problem and every challenge in front of us, we'll look at the SICK catalog and decide which is the right sensor to find the information our robots need to perform their job. So SICK sensors provide us very reliable data. We know what we're getting every time we use a SICK sensor. It lasts throughout the lifetime of a system, and it allows us at Titan to not worry about the quality of the data we're getting and worry about what to do with that data.
Hello, my name is Alan Bancroft. I am the Chief Operating Officer at Titan Robotics. So I've been using SICK for many years. I've been in the robotics industry for almost 40 years now. Been at Titan for several months, and it's great to see that Titan was already using SICK technology for many years as well. So it's great to see, as I'm coming into this organization, that SICK is still one of their main foundational sensor and navigation technologies in the organization. Well, we know when we open up a SICK sensor out of the box, it's going to work. So we're not ever really worried about building in time to make sure, hey, we're not sure if the sensor is going to do what the data sheet says. We have a lot of confidence in working with the technical engineers at SICK. We're working together to get the best solutions on our platforms. I'll tell you, one of the things that stands out to me with SICK, and it's not only just my experience using SICK at Titan, it's also my experience using SICK in other industries, that SICK is very, very responsive, because we have very unique technology that the team has developed over the last 10 years, and it's very unique in the industry. So we're taking the best of lots of worlds and bringing them together. So here you might recognize more of an industrial robot. This is from Fanuc, but we're also putting this on a mobile base where we have omnidirectional wheels, so we can move this platform in XY space. But we also make sure that our systems are always safe. So this will be operating in front of assets, and we want to make sure our robots don't hit things. So we have SICK safety and some other SICK sensors here, and we tie all that those sensor suites together and run it under our Titan Control software.
My name is Steve Turnchek. I'm a material science engineer, and I run the laser lab here at Titan Robotics. This is a custom enclosure that we've created to be able to scan the SICK mapping pod back and forth to create the 3D point cloud. The LMS is essentially the eyes that allows us to remove the paint from the metal. The mapping pod basically just works as intended all the time. It's one of the things I basically have to think the least about on the robotic system. The way that we're able to get such high levels of accuracy is really what allows us to be able to apply the laser with such a precise level of focus that's needed to be able to actually do our depaint process. And the mapping pod basically enables that.
Dave Galati, I'm one of the co-founders of Titan Robotics. My role has been the motion control and autonomy systems. So with Titan, we do high mix, low volume surface processing. That is, we're handling the parts that are the processes that couldn't be automated before. So the sort of the 3Ds, dull, dirty, dangerous, but in larger situations with a lot of variability. So I've done robotics for 20 some years now, all different fields, UAVs, UGVs, agricultural robots, self-driving, etc. Sort of, I would call it the gamut of robotics. I would say that there has been a SICK product on every single robot I've ever been working with. So we recently upgraded from LMS 400 to LMS 4000s in one of our systems. The reduction in noise, the ability, it made all of our algorithms work better. It made our system work significantly better. One of the things that we care about things just working. And the biggest thing that we notice about SICK products is we don't have problems with SICK products. One of the things that we found is that for a robotic system to be useful, it has to just work. It's one of the things that Titan focuses on. We focus on robots that just work. You've succeeded when you produce a system or a robot that does a thing that everyone looks at it and goes, huh, is that it? That's all it's doing. And that's exactly right, because they don't see the complexity, they don't see the problems that you've solved. It's one of the things we like about SICK, it's one of the things we appreciate, that for SICK products, you don't see all of the effort that went into it, it just works. We don't like to have customers or have a customer service relationship. We like to have partnerships. That means that everyone is pulling together for a common goal, and that's one of the things that SICK really helps us with. When we need something absolutely the next day, tomorrow, SICK is there for us.